You're not tapping on the.
He was answering microphone.
Oh, well, hopefully you can hear now, Jose.
Yeah. Good.
Okay. Yeah, just a very quick bit of administration. Quite a few of you, of course, are travelling to Grange this evening because we're meeting in the Commodore at 7 o'clock. And I think my understanding is from Christine that we've got enough car spaces to transport everybody who needs to go. So those of you who have got cars, if at the end of the meeting at 4 o'clock this afternoon, you stand up here and we'll do a bit of speed dating. So I'll put up my hand for two spaces and so on. Okay, so Philip's here.
Yes,
Okay.
just right.
Just right. Good. Okay.
But not as a presentation.
But okay. Yeah.
Yeah. Apologize. No, it's not the first.
Just press the back arrow.
Yeah, that's it.
I
Apologize for me using a text that prevents me of drifting away. Well, being here in this memorial symposium to celebrate Bob, a warm person and friend, dedicated and committed as a scientist who influenced and was a big inspiration for many colleagues. It always gives me a warm feeling, and I'm really enjoyed, as I was always when I was with Bob. At the end of the 1990s and the beginning of this century, as a result of the implementation of the commitments of the Convention on Biological Diversity and of the European biodiversity strategies, the need for appropriate and reliable framework for biodiversity monitoring, for harmonized data flow and cooperation within and between member states that was growing. And indeed, aggregation of data on the European community level and others, and comparability among countries remained very low and did not permit an effective monitoring and reporting of the state of biodiversity or the implementation of policies based on accurate data and evidence. Now, this was not only discussed in the European Environment Agency in Copenhagen, but also amongst scientists as Bob and colleagues when we met at symposia, workshops, and field excursions. And Bob then enthusiastically explained us the approach of the Countryside Survey. I was proud about the recognition that this survey got and the results and impact on the policy. Comparing this with the experiences of others that they had with their national or regional habitat and landscape mapping schemes and their limited impact and controversial results, that convinced us to join efforts and develop a comprehensive methodology for the consistent recording of mapping of the state and the changes in the countrysides and the habitats throughout Europe. That idea was gradually put into practice in a very collaborative and open way during field trips, for instance, to El Tiemblo in Spain and the Ecoland meetings. And Bob was key in that process. He brought everybody together, respected the skills and the experiences of each of us, and stimulated everybody to contribute. So in this way, the foundation for a fruitful collaboration was laid, which later resulted in the two successful European projects that others already have thought about. Now, central in that discussion was that the monitoring system, for whatever purpose or scale, needs an unequivocal terminology, a precise and reproducible methodology, and a robust and transparent data management. Also, these aspects have been touched already this morning. Now, for some of the elements of a monitoring scheme, progress was made in that respect, but at least one variable remained problematic, and that is the notion of habitat. Now, habitat was and still is indeed used in very different contexts. There is the legal one, the jurisdictional context, for instance, regarding the European Habitat Directive and the annexes. And it's also used in nature conservation policy. Think of the different classifications used there. We've heard about it. And finally, there's the definition or the definitions used in ecological research, which also vary from vague to broad. For instance, the place an organism lives in, to precise and narrow the set of resources and conditions a species requires. Now, in nature conservation, there exist a lot of typologies of habitats. Think of the UNIS classification, but all these have important shortcomings. And those shortcomings, they hinder reliable mapping and monitoring. It occurs that within one classification, habitat types may range from very general to very detailed, or habitat types are biased to particular regions, or they use local names, or they lack clear diagnostic features, or they use environmental terms that have different meanings according to the region you are in. A favorite example of Bob was always, dry in Scotland is something completely different as dry in Greece. And all this accumulated, of course, in the one central problem, and that is the lack of rules of consistent monitoring, recording. So the task of Bob and colleagues was clear: find a way to overcome these shortcomings. And it was agreed that the new typology should transcend species, at least for the general habitat categories, that biogeographical terms or local names should not be used, and that recording and mapping should be based on statistical rules at all stages. Repeatedly, these ideas are also brought this morning. Now, starting from the rationale that habitat is a spatial extent of a resource for a particular species, the idea was then that habitat could be made concrete by concentrating on the vertical complexity and the horizontal heterogeneity of vegetation, plus the abiotic variables, plus the landscape context. The focus should be on essential features that at the same time can be expressed quantitatively, which is needed for consistent identification and mapping, and that bear the potential for early warning. And as a consequence of the latter, the methodology should enable to record small but significant changes in the habitat that don't, however, alter the habitat type itself. Now, the solution found or used was working with plant life forms, which indeed define to a high degree the structure of a habitat and hence its quality for the species assemblage. And it's evident that the ratio of the different plant life forms is sensitive to changes in environmental conditions, in land use and in management, and thus may serve the purpose of early warning. Now, at the end, also that was, Rob already pointed at that, at the end, combinations of life forms resulted in more than 150 so-called general habitat categories that could be applied in the whole of Europe. Now, apart from the unambiguous habitat description, strict mapping rules are key to the methodology. And in the new methodology, they refer, also this was already explained, they refer to minimal area and length of mappable units, to 6 clear rules to distinguish between adjacent units, to 3 percentage bands to describe life form ratios, and important to regular quality control. Now, further detailing of the general habitat categories is achieved by adding the ecological conditions explained earlier, the qualifiers, well-defined qualifiers, very important, which cover environmental codes, global codes, site qualifiers, management qualifiers, details about species, and as a surplus, not obliged reference to European and or regional classifications and syntaxes. Now, Bob and his team, working in BioHub, working in eBOOM, were convinced that by elaborating all this, a more optimal mapping and recording system could be achieved that met the initial and overall objectives. Workshops and discussions with ecologists and with the European Commission and the Topic Center for Biological Diversity in Paris, but also with regional and local policymakers and stakeholders, with test campaigns in different biogeographical regions of Europe and beyond. All this improved the applicability of the method and ensured the collection of useful data, especially. Oh,
Just telling you 10 minutes.
Especially the reality check against the expectations and requirements of the end users was very informative, though an adoption of the entire recording process by European stakeholders never happened. However, the approach that Bob and his pack inspired many others in the approach of Bob and his pack that inspired many others in Europe to improve and extend their own methodologies. And I'll give some examples of that. So, for instance, to avoid misinterpretation and controversial results, the use of unequivocal habitat definitions and of clear and transparent mapping rules was incorporated in several existing methodologies abroad. For instance, here in Flanders and Belgium, the so-called biological valuation map, which is frequently used in environmental impact assessment, that struggled with vague and absent definitions and rules. When that map was only the background information source, that posed minor problems. But once that the map was also referred to in policy papers, and they were obliged to be consulted in land use permit procedures and jurisdiction, the legitimacy was questioned, which led to a lot of disputes. And therefore, to avoid these conflicts in the newer versions of the map, the approach developed by Bob et al. Was adopted. In other projects, instead of using only one entry to identify and define a habitat type, a combination of different tiers was used. So the units of land cover maps related to, for instance, development plans in many countries may consist of 3 different tiers: the proper land cover type that's defined as a general habitat category, plus a functional category defined as the land use, and a formal category defined as the legal status of a unit. So the information content increases clearly, but recording becomes more complex, especially when long lists of qualifiers have to be consulted too. Now, the application at that moment of recording apps with different maps, with drop-down menus, databases, etc., then they turned out to be very efficient. Also a development that was promoted by Bob. Yeah.
3 minutes. Yeah.
Okay.
Yeah.
That must be. Other related projects built on systematic approaches of habitat mapping, but added extra targeted qualifiers to describe, for instance, a habitat's potential to deliver particular ecosystem services or to promote the interpretation of cultural landscapes. But also then, strict definitions of mapping rules remain key. Now, following Bob's approach, respecting strict recording criteria to increase reliability, avoid subjectivity, became finally standard all over Europe, more or less. It proved to be very important to allow calibration with high resolution remote sensing data for mapping, for instance, habitat quality assessment. General habitat categories, a proxy for plant functional types and vegetation structure, turned out to be the attributes to which remote sensing was most sensitive, what means that classifying remote sensing data into classes based on the general habitat categories produced better results. To increase accuracy of such automated classification, the BioHab eBone approach in turn got valuable recommendations. The strategy to use square kilometer sites for habitat land cover mapping also allows integrated or nested monitoring, which link the observed state of habitats with recorded pressures in the sample sites. A methodology for such an integrated mapping was elaborated for Flanders with specific qualifiers to give insight in pressure state and impact for instance, desiccation and erosion. Unfortunately, due to budget cuts, it was never put into practice apart from some test sites. Now, after all, the emphasis on reliability and usefulness, so much advocated by Bob, strengthened the need to meet expectations and goals of the users in the most cost-effective way. Awareness arose that the success of a monitoring scheme not only depends on the developers, say the supply side, but also on the demand side, the clients and the policymakers. End users have to be explicit about their information needs and should realize that not everything is possible with one single monitoring. Priorities have to be set. Clients should think about the statistical quality of monitoring schemes, such as requirements regarding precision, minimum effect detection, degree of significance, resolution power. All this together define the strengths of the monitoring scheme and hence its usability. It's sad to say, but if no more attention is paid to this aspect, most conservation monitoring is, but need not be, a waste of time, as Lek and Nagy argue in the Journal of Environmental Management. And it's one of Bob's and also the Countryside's achievements that he encouraged statisticians to collaborate on this theme in order to further improve habitat monitoring in Europe. And so, thanks to the unwavering commitment and encouragement of Bob Bunce, supported and assisted by his wife Freda, habitat mapping and monitoring on a landscape scale in Europe was taken to the next level. Thank you.
Yeah, thank you for that very detailed and clear description of Bob's legacy in a European context. This was a very important part of his contribution. We've just got time for one quick question to get. I mean, he'll be around later, of course, yeah. But anything pressing that anybody would like to ask at this stage? Go ahead. Okay. Yeah, thank you. We'll come back to you. Roche, hello, how do you do? Nice to see you. It's such a long time. Bonjour. Has just arrived. So yes, we're going to, he's done very well. So we're going to just have a 1 minute hiatus for us to get.
Yeah. I have everything on the key, so
okay.
No right. Notes, nothing.
Nothing. Right. Yes.
Yeah, many pictures.
Yes.
Right. Probably best if I just.
So Air France has a good idea to cancel my flight yesterday, so I had to take one this morning. It was hectic. Yes. A long way.
Right.
Yeah.
If I just run that there, leave it with you there.
Okay. So I move with
the arrow keys there is probably the best one. Okay, I'll just try and just move that down.
Yeah, I won't cut many things anyway.
Yeah.
There's not a lot of text.
Yeah. Okay. Thank
So,
you.
good day, everyone. I was invited today to speak about the Mediterranean type ecosystems. Bob was very fond of the Mediterranean type ecosystems, particularly the Spanish ones, but not only. So what we worked for maybe for, like said Geert, the end of the 20th century, starting with Ecoland, BioHab, and eBone, developing this protocol. And Bob was very keen on having this protocol, the keys. Oh, sure, the keys is working or not?
Yes, probably.
This one? Right, it should be, yes.
That's just maybe not the focus.
It's all right, just press on there and then try now.
Yes. So here's the manual in the field. I took this picture in one of the field trip we had in Portugal, an initial one. where we're discussing about how to integrate the specificities of the Mediterranean landscapes. There are some specificities, but not that much. I will say that in the course of BioHub and eBON, I also discovered that the so-called high diversity of the Mediterranean landscapes is a bit more complex to describe using this very interesting protocol, because sometimes we end up having a much more diverse landscapes in Austria or in Slovakia than in Spain or France, because of the consideration of the scales of the vegetation patterns and the patterns of the landscapes and the land uses. But here, there's some ideas. Just a reminder, the region with the Mediterranean climates are on this map in the red colors. We haven't visited them all using the Bob protocol. The blue dots are the one where we went for during the BioHub and the eBON thing. So it covers not only the Palearctic region, but also some part of South Africa and Australia, where the protocol was tested with some interesting feedbacks. California was not really part of the eBON, but I went there and I checked also that the protocol was working. Just Chile, that is out of my regions. I also worked in Morocco, but not for the protocol. So here's a lot of pictures of the groups. We went in the field. The idea of the protocol is to test it and to revise each time the protocol, define the qualifiers like precise. Maybe of us this morning, but I wasn't there. So you can see many of some of the people here in this room, maybe the hair are a bit more gray. So field work in Spain. This was in Andalusia, this part. In Israel, we went also on a specific workshop about Mediterranean type ecosystems. In France, well, we had one of, you can see very similarities of the landscapes. So there's commonalities there. In Greece, where there was a team in eBON working in Greece, but we do also some monitoring and control of the quality of the protocol as well. Very important to check that. So what can be defined specifically of Mediterranean type ecosystems? Particularly is we have some specific plant life forms, which are the image of the Mediterranean type ecosystem are the shrubs. The shrubs they are principally evergreens, small shrubs, sometimes spiny, sometimes having losing leaves in winter or in the summer. So you can see this type of things in the Palearctic zones, I would say in Europe mainly. So the Mediterranean scrubs are found in every of Mediterranean type ecosystems over the world. In Australia, you have them, in South Africa, in Chile, everywhere. There are different names here to remind it. We have the local names. It can be garrigues in France, but it can be garrigas in Spain also, or in Italy. It's not exactly the same vegetation. Funny one. You can have the chaparral in California, the fynbos in South Africa, the freganes in Greece, or the Mali in Australia. And so we can continue. But more or less, they are defined by shrubs of different size. The classical scientists working with Mediterranean vegetation, specifically the Spanish and Italians, they use the common names of matorral. It's for everything. It's covering everything. And you can define it with according to size, with the high matorral above 2 meters. It's what we call maki in France, macchia in Italy. And the low matorral before 60 centimeters, they can be like freganes or some fynbos in South Africa. And we can find that into the protocol of eBON defining the plant life forms and then the GACs. If I take the category of the shrubs, the TRS, the trees and shrubs, then it was defined in the protocol according to height, and you can find the first level exactly as defined by the Spanish and Italian workers from the 50s and 60s, this level. And then we subdivide them a bit more according to the FPH, the forest phanerophytes, the big trees, up to down, you cannot see them, the DCH, the dwarf campophytes, but you can find also in the mountains or in the Arctic. What we can define here also, we can use local names, but mainly what we find in Mediterranean type ecosystems when you are in the coolest and And the wettest is on top left for you, is where you find the forest, dominated principally by deciduous, winter deciduous, like you find everywhere in Europe. Is a bit different in other regions of the world. Then the big green square is the area of the forest and the tall shrubs of evergreens. And then if you are more in the warm regions, you can have different stage of the high shrubs, evergreen, and then when you go dry, you have the additions of the summer deciduous species. They cannot maintain the leaves during the summer, it's too dry. And then in Europe, you can have a big group, which are the conifers. The conifers are everywhere. Yeah, in the very dry places to very wet spaces, and they overlap the things. I'm trained meteor ecologist in France, and for us, the forest of the pines is Aleppo pine in south of France mainly. It's just on top of the rest of the vegetation. They have no specific vegetation. It's just a tree on top of the matorrales, I would say. Not to be quick. You know that, maybe you have seen it before. Up. So what we have done in these things is delineating the parcels on for having these kilometer squares that was presented. But the question is how to delineate these elements. Specifically in Greece and Spain or in France, you have a big continuous between the sparsely vegetated areas to the forest. Because of grazing, because of fire history, because of many things of history, of use. And then sometimes it's very difficult to cut out these polygons. It's why we ended sometimes having very not so diverse kilometer squares in meteor-type ecosystems, because we don't know where to cut them. You can cut them in many places. So just, and also the interest of it is having this very harmonized and specific protocols with rules is the main part, and you always end up into achieving a correct classification. Up. One of the things we addressed in the meteor-type ecosystems is the history of use. And we added quite a lot of qualifiers during the course of UBON and BioHab. These are old terraces. So they were once cultivated, maybe somewhere in the 17th, 18th century. They were abandoned, gray certainly, and then they have been burned 7 times, lead to this cover of this matorral or this MPH, LPH evergreen vegetation. And then also you can see pictures where you need to cut down. There's an old field in the middle where you can find some hemicryptophytes and some deciduous or small shrubs. So you have to define it. And all the categories are able to do that. Here, maybe you don't see it. I don't, here's a pointer or something.
Probably if you just move the mouse.
Yeah, maybe. No.
Oh, it did work.
Did it work? No, no problem.
Just
anyway,
move the mouse over. You can see the.
Yeah, it's not very important. What we can notice here is MPH evergreen NLE. So in the GIC wording is medium-sized phanerophytes evergreens and non-leafy evergreens is delineated because there was a fire here, and where you can see the conifers, which are MPH cones, so they are low ones, new ones is regeneration. And this can be mapped adequately using the protocol. What was, like I said, I'm not going to develop, also having vegetation samples added to the top, so you give a lot of information. Oh, adjustment. So we have a variability of the GIC within the landscape, the square landscapes. It can be a search on the left, the forest of deciduous, to the down on the very dry, low phanerophytes, we call the garrigue in France, low matorral, I will say, and then in the LPH evergreen in the GIC wording. And then you do the vegetation survey inside the protocol using this 400 meter square protocol. This was very important. Like Geert said, it gave a lot of information that can be used for something else. Yes. After it would be just pictures. So I pass that. So what I have seen working in other regions of the world and Europe, in South Africa. South Africa, here is a picture of the Cederberg Mountains, a bit north of Cape Town. it was adequately covered by the protocol itself, except that we have so many species of LPH evergreen. You can have 80 species, and then you move 10 kilometers, you have another 80 species, but they are all LPH evergreen. It's a bit difficult sometimes. Here are two pictures. On the left, South Africa, and on the right, Spain. You can see very similar features. You simply have a bit different set of species. On the right, you have in Spain Camerops of Milis, a small palm. On the left, and aloe ferox, a tree aloe. So how to code that was one of the discussion we had with Bob. Should we add new life forms? I proposed myself to add the stem rosette succulent types. I was not so happy with that. Yeah, it was also using the TPH evergreen and then using a life form qualifier. If you know by heart your manual, you will use the code 268, and then it will mean that is a succulent. So it's two ways to do it. In Australia, we have another type of strange, funny bushes called tree grass. And then you can call it also like a TPH stem rosette evergreen, or if you use the life form qualifiers, then it would be TPH evergreen or NPH according to size. Qualifier 275, which is tree grass. So we don't lose the information. So just another picture to see the shrubs in Australia. I took this picture in South Africa because I have some questions from my own bloggers. Because I say we have 1 kilometer square and one GIC. There is no other, just one big polygon of 1 kilometer. This was completely homogeneous, so I have 4 pictures on every side to show her. So everything is LPH evergreen, somewhat deciduous, but with 50 or something species different. So we have a fine scale heterogeneity, but very large scale homogeneity. A similarity also, and we'll finish after that, is a grazing. So in France, so sheep grazing. In Spain, in Sierra de Gredos, we have cow grazing. And in South Africa, we have something different with the eland of South Africa. And I didn't took the picture with the kangaroos in Australia. So to summarize this work with Bob about Mediterranean, is that it proved to be robust. We tried crash test in different situations. It proved to be robust. Just minor adjustment was supposed to, even including regions where were not initially supposed. It was supposed to be European. It was successfully applied in our region like Australia and South Africa, just with marginal additions like qualifiers of some species. And for me, the GAC BioHab/eBond protocol is still up to now the most comprehensive and harmonized protocol to record landscape, habitat, and biodiversity. So it can be used with many things. So just finish with this one in Israel. Goodbye, Bob.
I can do it for you.
Philip, thank you for an excellent talk. Some great pictures, and I hadn't realised, of course, that the BioHab bone had been tested in other parts of the world as well, outside of Europe. So yeah, that was interesting. Time for a quick question to Philip. Anybody? Yes.
Problem because there we go. That should be okay now.
Is it possible to say which habitat type you define in terms of scheme of development?
And we had these problems in South Africa, particularly because of the very high diversity of the tree species, the shrub species. And then it was very difficult to use the 30% threshold because there was no species reaching 30%. So in that case, we were recording the main glyphos, but they were a bit the same. So we were a bit puzzled how to do that. We were missing a bit some information because of this very high alpha biodiversity from South Africa. From us.
Thank you.
Thank you.
Okay, anybody else? Right. Okay. Thank you. Philip, and especially so having just arrived. So over to Helle, who's going to talk about mapping landscapes and vegetation in Sweden.
Yes.
I'm going to click. You just click on your name, and it should bring it up. That's it.
Yeah. Okay, thank you. So I will talk a bit about not this square kilometer perspective that many habitat monitoring people use. I'm more integrated in planning situations, so giving municipalities or regions a way to plan their urbanization of landscape and also follow like habitat not monitoring, but habitat network analysis, etc. It's a very spatial thing, so it needs complete coverage, not square kilometers. But in my work, I have had such good use of the inspiration I got from Bob, and also being consistent, having classifiers, being very transparent and in definitions, etc. It has really been a useful thing to bring also into these complete mapping. So in Sweden, there has been a long vision about having regional mappings. The Stockholm municipality was really early birds already in the end of 1980s. They created their own biotope map, painstakingly, air photo interpretation, analog images, really a lot of work. And it has been discussed ever since that, you know, we need an update. We need to have frequent updates. We need to have larger coverage because every unit like Stockholm is confined by border problems. So you need a lot of data of the surrounding landscape in order to even understand how the species are thriving inside your own administrative borders. So I started working on a new method using, I will speak a bit more about the method just showing now, to actually create this regional database. And with lots of brave municipality throwing in some money, giving us opportunity to develop this method. Actually, we have covered now the whole regional area of the Stockholm County. So it's 6,500 square kilometers that needs to be covered in order to get these regional perspectives of landscape patterns. So how did I do it? Well, it's also not a matter of having a really large map of a region. You need to be able to zoom in. So this is one of the smallest municipalities in Stockholm. And also from that, you need to be able to actually go down into a landscape patch scale. So it cannot be just too much overview. And it's also in a vector format, so polygons, making more sense for planners, describing things. You know, it's not enough just to have pixels or something. You need to have a lot of spatial context. You have arable fields, you have forest patches, you have urban patches. Typically pink would be urban green structure that actually is not just black and white. It's a lot of information. It's a lot of biodiversity possibilities also in the green urban structure, especially if you're talking about the town region, that you need to be able to see how the flow of species and organisms can be through also the fabric of urban green structure. So that's why it has been added quite a bit to be able to well, integrate the rural areas with the more urbanized areas. And the way this method is constructed is it's a hybrid method. So to start with, it's collecting lots of existing data, compiling them into a way to map a step one database. So even before you add some human perspectives or brains to it, it needs to be kind of as rigid as possible and robust to then add on what you cannot get from automatic methods. You need to add information about land use, for example. You need to fill these parcels with additional information, just like Bob and the Countryside Survey is doing in their own small parcels, but this is on a larger spatial scale. And the data that is used is basically what Sweden as a nation provides. It's a lot of photogrammetric stuff where I actually do not use satellite images. I use the forest classification from the Swedish, the national, it's behind the land cover data to the right. I actually use their forest classification because it's satellite based. It's the best you can get on nationwide. Otherwise, it is color infrared orthophotos. It's ground model, surface models to actually be able to describe the height of the vegetation. Historical arable land is automatically deduced from land cover, not land cover, but arable maps from the 1950s, a lot of national road and railway database for the infrastructure, various parts of the cadastral map of Sweden, and then the quaternary deposits map. Very important to actually be able to see what kind of if it is coarse sediments or turf or bedrock outcrop or somewhere in between. It really is significant for what you can expect, what kind of vegetation would be in there. So this is on a completely different level, but it's supposed to give a context to more detailed mapping, like the countryside survey, for example. So not getting into the total classification system, but basically it's seven really broad habitats or biotope types. I actually had brought up this confusion with the habitat concept. I don't use it at all. It's rather just biotopes, and then you need to combine it into habitats depending on what species groups or organisms you're actually looking at. That would turn this data set into a habitat map, for example. And then also looking at, I have various, not only 1.1 square or 1.1 hectare as minimum mapping unit, because in many maps you would have like tiny arable in islets or road verges between arable fields and other areas, or really small water ponds or tiny islands. And they will be kept in the database, even if they are far too small. They just need to be labeled up as being too small, but keep them in the database. Otherwise, they will be just removed as slivers somewhere in the process. And then additional descriptive attributes will be, of course, land use. Some of the land use is known. You can get it from various maps, but a lot of the land use is actually really not known on a really detailed scale. You don't really know if it's grazed or not. So that's where it comes into the step 2 part, where actually someone needs to be looking at air photos, or you need additional information for that kind of detail. So I built this as in ArcGIS Pro, building toolboxes, doing everything iteratively, that I can do it from data from anywhere in Sweden, just feed it into the pre-step 1 toolbox, actually transforming these maps, picking out the information that is needed, and then compiling everything in the step 1 toolbox. And at that stage, you will see the small parcels above. It would be one municipality, for example, and in the in-data could cover the whole area, or it could be just cut up in tiles, like the author photos, for example. And when doing those analyses, you might do an iterative process, doing the same thing through all these tiles and then putting them together at the end. And also, if you step 1 tool, you need to do the whole database, compiling and boiling down all these in-data to a proper database. It might have to be done in separate tiles. So the whole data set will be cut up in smaller parts, or the computer would just choke of all the details, running through everything. And then in the post step 1 toolbox, it would actually stitch things together, do cleaning up, making the database complete, adding some automatically derived attributes, for example. So that's kind of the whole process. And would look like this, the whole chain. The iteration is either run inside each tool, or we have developed some Python scripts to really make things run. So you can go, if you have a large area, it can run for weeks. It will still, in the end, produce a biotope database, step 1, the complete automatic thing over an area. It only consists of 2 manual elements in the whole part, and that's looking at arable fields that might have been exploited, built or something, because I use the arable fields as paste it over anything else, but then I need to retrack myself and see if anything actually has become something else. Also looking at the green roofs, it's a hype in Sweden. Many new buildings have green roofs, and if untreated in this biotope database, you will have tiny forest patches inside the city that really needs to be dealt with. And of course, some people would be interested in monitoring or seeing how far away the green roofs are from each other, and do some studies on them. This is an important, I won't dwell on it much, but I think we have been discussing, this is basically, I would say, how Bob would think, or the projects, that negotiation is really important, and mental understanding. When you come up with a new classification system, you need to make sure that you don't just invent something and then you impose it on people. You need to go, through the persons coming up with it, and then those who will actually make the database, they need to understand. Yes. And then you need to negotiate with the users, the end users, and everyone needs to be aware of the limitations and everything in the databases, how they will be used. So I think it's really a good thing, because someone title said that landscapes are more stable than we think. I would say that the perception of landscapes is less stable than we might think. And this, the cat syndrome, it's actually inspired by Marc Metzger. It's easy for us knowing the context to see that it says the cats, but for a computer or someone who has never seen a cat, it's difficult to actually get this, especially if you tell a computer to make a map for you. It's difficult to really get what you want. Otherwise, bridging perceptions, I think Bob didn't only tell us what to do, he really brought up this team negotiation part, which is really important, that we really look at a patch and we know that we perceive it as the same thing. And I would say it's just exactly the same thing in the lab, working with computers. You really need to negotiate a lot about boundaries of classes and how to tweak and set up all the automatic stuff in order to understand. Also, when you work with landscape data, you need to remember that the same thing could be really stable, like a reed belt, looks very different early in the spring and in the summer. So if you do this automatically, you will actually miss a lot of information if you're not careful. I solved this by actually adding a date for the acquisition, so people would know that they know there is water vegetation, but it's not here because it's early spring. Also, this just the same grassland patch might look very different depending on seasonal time and also the ongoing land use, grazed or not. You need to make sure to understand that if you have a computer doing spectral analysis, this would be maybe a changed landscape, although it's very stable. So you need to make sure to look at that. Also, the complexity. This project, the green part, has been developing since 2012, but even rests on a lot of old experience. And Bob, there are some Bob moments all the way from early end of 1990s, both with the Countryside Survey, BioHab, eBone, etc. A lot of good input for this. And field work with Bob, as we have all experienced, was always such a treat. And sure will be he sorely missed behind her. Yes, thank you.
Hello, thank you very much indeed. Yes, but, you got through a lot of information, lots of interesting points. Questions to Helle before we move on?
Do you have a sort of ground truthing protocol for the maps? Or
Actually, well, it is embedded somewhere, but it's supposed to run even without possibility of ground truthing. It's a preliminary product that it's remote sensing. It actually builds on other maps. So some people have asked me, what is the precision in mapping this and that? And I would say, well, it depends on the 1950s map. How precise is that? We have no idea. It depends on several other factors. So I actually added some estimation of trustworthiness. And then this map product is actually supposed to be refined and further elaborated by the users. But it's supposed to give more contextual information than not having it at all. Yeah.
Is your map used as a preliminary ecological assessment if the development wanted to go ahead?
That's the idea, yes, to actually have a broad. I have discussed with municipalities saying that they say that they could use it in the first stages of exploration to actually see what would be a potential problem. If you have grasslands or if you have broadly deciduous forest, you might run into trouble. So it would actually give an early warning, and then you of course need to go out in the field to see what species there are. So they're not, so it is a preliminary, also used a lot for ecological modeling.
Do you worry that municipalities might consider it as being too close to the truth and then say you don't need to do a proper survey and just
I don't think so. I think they actually know it's legal stuff. They need to go into the field, and they will actually do that. But I think it's actually very constructive for them used to actually say, why should we keep this little forest patch? It's just a little forest patch. And with this regional map or for the whole area, they could say that, okay, but this is really a stepping stone. It's unique in its way and it needs to be preserved, blah, blah, blah. So it really gives them arguments for how to treat things that seem to be not so important, but actually have regional importance or in a wider scale.
Hello, thank you.
Yeah.
We should move on because time is a bit pressing this afternoon. Thank you. So we're going to finish this session with Felix from Zurich in Switzerland, continuing with this session on international monitoring. Right, so Felix, if we just click on you, your slide should come up, this clever system that David has devised. Over to you. Right, thank you.
Yeah, first I would like to thank you for organizing this. I think we all enjoy it a lot. I will be kind of repeating many things that have been said, but in a different context, in our national context. I use this map to explain that Switzerland is not part of the European Union. And I realized that there should be a second white island. I have to update that.
I think people are laughing because the blue island should be white now as well, I'm afraid.
Yes,
Much to our chagrin.
Yeah. I know, I have to update that. And so, yeah, we have our own environmental policy, as you're also having now. Just a few words on Switzerland. We're famous for being a mountain country, but most people live actually in the lowlands between the two mountain ranges of the Alps and of the Jura Mountains. And this is where we have a lot of pressure on the land by infrastructure, industry, housing, recreation, and intensive farming activities. And we have land abandonment in the marginal regions, as everybody has. We have a diversity of agricultural production types, so intensive farmland in the lowlands, also a lot of livestock. We need milk to produce chocolate. There is more extensive mountain farming, lots of grasslands, and we have special crops, vineyards, vegetables, etc. This is how the Swiss agricultural policy evolved and how the monitoring and evaluation processes were linked to that. So the first voluntary programs came in the early 1990s, then cross-compliance was put in place quite early. And in parallel to that, there was a comprehensive evaluation program that was started. And when that was over, the government wanted to have agri-environmental indicators and monitoring, including also biodiversity. And we look at biodiversity on the one hand with the LCA approach and with a proper farmland biodiversity monitoring. And this is my and Bob's timeline, how they fit into that. So I had migrated to Germany in 1994 because in about 92, Switzerland voted against joining the European environmental area. The economy stagnated and I found a cool job in Germany. And there I worked on landscape metrics. And that was the time when you wanted to make an international phone call, you had to go to the secretary because she was the only one who was allowed to do that. And there was no email. So I called Bob from that secretary, and this was our first contact. Then I attended a couple of ialeUK conferences. From this, there were various European project collaborations, many have already been mentioned, and Bob helped us to put up this farmland biodiversity monitoring. So this monitoring is called ALEMA, which stands for a German and a French short sentence. And it's actually there to test whether the agri-environmental objectives of the government can be reached. So it has three purposes. The first one is monitoring. The second is the evaluation of the agri-environmental policies, which is, I think, very important and valuable because this makes it useful for policymakers. And then we can also use the data that come together to answer short-term questions, which policymakers, administrators always have. Bob was very interested in design, so I will briefly explain our design. In the early 2000s, general biodiversity monitoring was launched in Switzerland based on a regular grid sample of square kilometers. And when we had the opportunity to develop a farmland biodiversity monitoring, we selected a subsample of those squares. And it was a stratified sample this time of squares which are dominated by farmland, and they were selected to be representative for the main 5 agricultural zones of the country. And then in each square kilometer, we had a regular grid of 50-meter points. And at those points, we do habitat classifications and on a subsample again, plant records. And we can use also the butterfly and bird records that come from the general biodiversity monitoring. So to use as many synergies as possible to get as much information as possible with as little expenses as possible. So what happens at those points? We have indicator species and habitat recording in a 10 square meter circle, and in a broader circle we look at structures and neophytes, and then, as I said, in a subsample there are vegetation records. So this is, of course, we have learned a lot from eBone and tried to adapt that to our situation. And we end up, it's a rolling survey, so after 5 years we end up with 33,000 habitat points and about 5,000 vegetation records. These are the habitats that we have mapped. So you see it's a lot of different habitats. It's quite differentiated. We don't use the biohab key, but we use the national key because the ministry wanted us to use the national key because this is what speaks to them. We have, of course, although we stratified it, we have a lot of habitats. They are hidden behind the screen here, which are very frequent. It's mostly the fertile grasslands. And then there is a long tail of rare habitats, which can then be aggregated in the analysis. When we started to design this monitoring, our starting point was to have wall-to-wall maps in the square kilometers to implement the biohub approach. But then in the negotiation process, the people who were going to do the work said they cannot do it. They cannot draw the lines in these gradient landscapes of grasslands. And this is why they went for points. So we did points. And now, after some experience, we realized that even at 10 square meter points, you may have different habitats. So it remains tricky. And Bob always said, you just have to make a decision. So we're stuck with that still. This is a paper which is just coming out, which now analyzes the first 5 years and can kind of explain the farmland gamma diversity based on the main drivers for farmland biodiversity. And for us, of course, land use intensity and ecological focus areas, agri-environmental policies are the interesting parts, which we can then also inform the administration about. I will not explain this graph in detail. This was a more pointed or more specific evaluation we did with already a part of the samples in the process of the evaluation of the agri-environmental policy, because that was when the data needed to be delivered. It shows the effectiveness of specific ecological focus areas in grasslands at different elevations. And it got quite some attention by the farmers and by the policymakers and by what we call the green press. But this is very specific for Switzerland. Now some pictures. This is Bob and the other person is me 20 years ago, where I tried to learn how to map habitats. Then the BioHab project with Gabriela, some of you already asked about her. She now works for a cantonal administration, explaining farmers on how to manage biodiversity on their land. So she's very applied, working very applied now. The SAFE project was the first big agroforestry project, European agroforestry project. Joao sent me this picture, he is there, and Bob explains the elephants on his, what do you call that? I think must have been the PhD defense. Yeah. Then we also had the BioBio project, the Transhumant project together. Here he's working with Ilse on the computer. Here he explains how to map habitats to colleagues from Uganda, from the Ukraine, and from Tunisia. And I would like to end my presentation with this picture, which shows how many of the long field days and of the long working days ended. Thank you.
Felix, thank you very much for a wonderful presentation. Any final questions? We've just got probably time for one, Simon. Yes.
So you talked about using the data set to test the effectiveness of agri-environment schemes, and that's something that's exercised us a bit over here using our Countryside survey data and others. And I wonder whether you've encountered any difficulties, and if so, how you've solved problems of trying to store and then access information on the actual agri-environment prescriptions and how they've been applied by the farmers at field scale going back in time to enable you to do that assessment of areas which have or haven't had agri-environment management, because that's the thing that's really testing us.
We're lucky, we just did the first survey, so we don't have to do timelines yet.
Right.
And I think we will come back to you later. Explain us how, what we should think of.
We'll try and do better then.
Any other points, comments, observations, questions from anyone? Yeah, do you want to put that in chat? I mean, I had a quick question for me. I mean, as two countries now, both outside of the EU, are there any? Do you see any comparisons or synergies between the way the UK is now approaching agri-environment outside of the EU and the way that Switzerland is going?
That's DG Agri on the chat to comment on Felix's talk.
Oh, there you are. Yes, yes, exactly. Yes, yes.
They can talk to Wales because they've been a good guinea pig for a while as well.
Yeah. Okay. Yes. Yeah.
Just trying to get
Yeah,
back.
I don't know how your scheme is evolving now. I'm participating in a Delphi survey. I should actually do it still.
Yeah. Okay.
Where they try to come up with something. I
Yes,
don't know where you're standing.
Well, this whole concept of public money for public goods is it sort of moved away from this idea of a subsidy, but it's got mired in UK politics, I would say, at the moment. So there's not much progress. I mean,
Sorry, you're doing modelling. Do you want to do modelling
we
next?
better move on. Okay, thank you, Felix. Yeah. Yeah. Okay.
Yeah.
Right. Hello, everyone. I thought I'd have a slightly grand title on how the Bunce land classification conquered the world, but maybe it's kind of true as well. We'll see. So it all started with the stratification work for the Countryside Survey, as everything we've heard today sort of starts off with the Countryside Survey, or the work leading into the Countryside Survey, with Bob wanting to stratify the country in different environmental classes to have a better distribution of the sample points for the survey. The classification methods were being developed at that time with Mark Hill, also at ITE and later in Cornell in the States. First, ISA is the predecessor to TwinSpan. Lots of ecologists will know about TwinSpan. ISA was the early version, and that was a co-authored paper with Bob and Mark Hill. They used that methodology to come up with a site classification for the woodland survey that Claire talked about, and then in 1978 for the Countryside Survey. Computing techniques were very limited. Ralph Clark is in the audience. He did a lot of that, all of that work. And initially, they couldn't make a map that covered all of Great Britain. They had a grid square, and on that grid, they had sample points, and they could classify those, but they couldn't do the whole country. Later on, through various quite complicated and difficult choices, a decision has to be made, and the decision was made by Ralph. They ended up with a GB land classification that has gradually expanded and probably has Northern Ireland in it by now. And over the years, other countries took inspiration from that approach to design your sampling scheme. So we've seen Thomas's map from Austria in one of the presentations just now, but Ramon, a good friend of Bob's who visited ITE, developed a land classification for Spain. There have been land classifications for Norway, and more recently, Miguel, who's sitting here in the back, developed one for Estonia. So the idea of developing a stratification went across Europe to various different countries. And at one point, I was working on my PhD, and I needed some kind of stratification, broad climate zones, more detailed than the type of Köppen or Holdridge maps that you might have in your school atlas. And Google was around at that time. And I found a paper that seemed to do what I wanted to do. And you might recognize the name of the editor of that book that I found in the Wageningen library. And that was Rob Youngman. Well, didn't find it in the library. I found it in the catalog of the library, but they had lost the book. Luckily, I knew that Rob Youngman was one of my university professors. I knew he was in Wageningen. He'd moved from the university to the Altera Institute. And I sent him an email, and I got a fairly instant reply saying, how about you drop by next Tuesday afternoon to pick up the book? Well, that's fine. I walked into the office, and it wasn't just Rob, there were two people there. There was also sort of this slightly elderly Englishman called Bob Bunce sitting there, and they said, well, great to see you, here's the book. And the book had these maps in it of Europe, developed for the Tiger Project that I think Paula was one of the people who worked on the Tiger Project. Anyway, I said, here is the book, but actually that map is not so interesting. It's not that great a map. I have an idea. How about you create a better map? And that would be brilliant for your PhD. And we can work together. I know how to do it. Fine, good. Various iterations, and took quite a while. Quite a while later, we ended up with this European stratification. My main PhD supervisor was a very laid-back person and said, you do whatever you want to do. And he didn't mind that I basically spent 1 year of my PhD, or largely 1 year of my PhD, twiddling away and making this map for Bob. But it was a similar idea to the original one, different types of statistics, different types of data, but various climatic, mainly climatic variables, principal components to reduce redundancy, and then a clustering technique to come up with 84 classes, which we aggregated into zones because Bob had learned from the UK that zones are easier to communicate and very important, have nice colorful legend and have good names. So we made some decisions about the names and the legend, and that data set has been quite successful initially for things like the BioHab project. So here you see again the test sites where BioHab went. Later also for eBone, where it was used as the basis for the European sampling or monitoring scheme. And so BioHab was all about the field protocol. eBone was also about applying that and having the statistical design to go with it. But then actually that data set began to lead a bit of its own life. Lots of people wanted to classify things in Europe at the time. lots of complexity out there, and how can we map that in nice ways? More data was becoming available. So for one project, we wanted to have a rural typology to understand what is happening in different places, how subsidies are used, and who knows what. So we could do things with the economic density and the accessibility and square kilometer maps, but then specify that for different environmental zones. And there's lots of examples where people have used this data set, and also not just me, other people started using it to create more difficult, pretty typologies, classifications, and things like that. In the meantime, also the European Environment Agency picked up on this thing, and they put it on their website as one of the key data sets for Europe. And they used it in a couple of their reports trying to define high nature value farming systems. So they're different in the southern Mediterranean than in the Northern Alps and things like that, to figure out bioenergy usage, how much bioenergy can Europe produce without harming the environment. Well, some of the thresholds are different depending on where in Europe you are. They needed to have a good definition for what different parts of Europe were, so they used that data set. And then at some point, IPCC knocked on my door. It helps, you know, the chapter lead author for Europe. And he said, well, actually, you want to summarize some of our findings for different parts of Europe. There was a bit of toing and froing about how many different zones there could be. They felt that 13 or 12 was too many. So a few of them were aggregated. But we had a European map that follows the boundaries of the stratification, and some summary tables where they talk about Southern Europe and Atlantic Europe and Alpine Europe and Northern Europe, and different trends for different types of impacts of climate change. So that was sort of a European success story. That all sounded very nice. And of course, Miguel picked up on the techniques. So he used very similar techniques to the ones that I used to develop a stratification for Estonia. The original Tiger project used discriminant functions to model the shifts of these classes into the future as a very simple early climate change impact model or climate change model. And Bob said, Mark, you can do this too. You do it like this and that, and we can have an idea of how things shift. So you use your principal components of your original clustering to put your zones in environmental space. You can figure out how they shift from one to the other with amount of size of change and direction of change and so on. And you can have these maps on the side where you see, well, also partly behind the zoom thing, but you can see how these zones or classes shift. And that's quite insightful. It's not a complicated climate model at all, but you do see that the four most southern strata, which are mainly based in Northern Africa in the 1990 baseline, how in the future for different climate models, these all shifted to Spain. Well, it doesn't take a complicated crop model or a complicated biodiversity model to understand what these, or have an idea of what the implications of these changes will be for southern Spain. So it has a very strong, easy narrative to discuss with lay people what climate change impacts could be. That was Europe. That sort of modeled on for a while, but then the eBone project came along, and eBone said, well, we're going to develop things for Europe, but we're also going to contribute to the GeoBond process of a global monitoring system. And for that, we need a global stratification. So Mark, do your thing. And so we did a very similar thing again, tweaked a bit with legend colors to make them even sexier, grouped the zones in a way that they were hopefully understandable. And we came up with 125 classes for to cover the world. We discussed how that could be used as a global monitoring framework, potentially in a handbook that was published by Springer. At the same time, within that GeoBone process, some people from the USGS were involved. There was a guy called Roger Sayer, and he was in his end 50s, and his mission before he would retire was he wanted a pretty map of ecosystem classes for his wall when he was going to retire. That was his mission. He had 5 years to produce it, or 7 years to produce it. So he said, well, I need a climate layer, so that in the bottom corner of the bioclimate layer, that is the stratification that I developed with others. And he just overlaid it with the best data that he could get, including really sexy high resolution 20 square meter landform data that the USGS had just developed, and made this really pretty map. I'm not sure what it's really useful other than for wallpaper in his office, and I hope this is buried enough in the Zoom recording that no one will hear me say that later on. But anyway, he made that map. And then of course, these global classes can shift as well if we add some functions to it. So by that time, I had a student and I said, oh, you want to do something interesting? How about? So he did it for 63 different climate scenarios. And this is an example again of Northern Africa and Southern Europe. And the green colors show where strata appear that hadn't been in those areas before and how often they appear in the various climate models. So dark green says that 63 different climate models say that a new class has appeared there. And I guess in the south and the Northern Africa, you see places where actually that climate condition doesn't exist anymore. It's all moved into Europe and there's new, more southern things going in. Then I got an email from Robert Sommer, who works for Isimot in India, or in northern India, and he had a cross-boundary project in the Kailash sacred landscape, which covers China, India, and Nepal. And of course, we know that lots of ecological data sets, they stop at the border. So he needed something that went across the border, and the simple bioclimate zones work very well. And he gave them local names that looked good, but they're actually just the bioclimate classes that I developed before. And he showed how from the baseline, which is the one above the legend, into the future under different climate projections, how basically warmer climates go up the Himalayas, and sort of interpreted what that would mean for local vegetation and for local fauna as well. And that got picked up in the Times of India. Climate change threat looms over the Kailash, Mansabur, whatever, says a new report. 3.5 million people read or have a subscription to the Times of India. It's the largest circulation of any newspaper in the world. So that was a nice bit of sort of PR press for this type of approach. And Robert then moved to China, to the Kunming Institute of Botany. And he thought, well, I can use it here in a project looking at a Chinese, what do they call it? They don't call it anything. Anyway, so that type of municipality, local authority type of thing, where there's a lot of expansion of rubber plantations. And so his idea was, how is the suitability for climatic suitability for rubber, how is that shifting? And is that shifting into protected areas in the region? So the hashed areas are protected, but actually you see that the greenish colors, which are good for rubber, they tend to shift into the protected areas, and rubber has expanded very rapidly in that region. And so the learning from this is that probably the protected areas will be under severe threat for rubber planting, not just yet, but within a couple of decades, it will be suitable for rubber, and will protection legislation be sufficient? Of course, if you can go forward in time, you have a data set, you can also go back in time. So there was another student who went and looked at the mid-Holocene and the last glacial maximum to look at suitability for lions. And so the present lion suitability is in the top map. And then there were two other maps, of which one we cannot see, but it shows that actually in the past, there was a very high suitability in the, well, just under the Sahara part of Africa, which actually there was a lot of debate about in the paleontological literature about how that is connected and whether lion populations were connected or not. So anyway, this showed that they were. So on that note, the Bob Bland classifications probably has sort of, anyway, it's gone global. People have been using it and making some interesting conclusions. All that feels kind of novel and exciting. And then I looked into I remembered a paper that Bob wrote in 2002, before I'd even met him, or just around the time that I'd met him. And the abstract is that although the details of the classification, he was comparing different classifications in Europe and Spain and Europe and Great Britain. And although the details of these classifications differed, there were broad similarities between the classifications, and these differences reflect important divisions along major environmental axes that have been inferred by earlier biogeographers. As the divisions are real, there is a sound basis for their use in the future for land use and environmental policy. And actually, that's sort of the conclusion that still stands, which is kind of nice, but it also shows that actually the amount of sort of novelty and new things that I've been doing with this thing over the last while is maybe also somewhat more limited. But anyway, some wise words from Bob in the end, and it does show that some of his methods traveled in time around the world and even back in time to the mid-Holocene. Thank you.
Well, thanks for that wide-ranging talk. Don't go away. There might be a few questions. I remember Bob more than 25 years ago, before climate change was really sort of in our consciousness, saying, oh, you know, the North Africa climate zone will spread into southern Europe, and we say this quite often. And of course, look at this summer and what we experienced this summer. Questions for Mark? Anything? Pete and
I had two major mentors in my career. One was Mark Hill and the other was Bob Bunce. And first time I met Bob was in Mark's office, and I think my life changed forever after. We had some Bob writing some of Mark's diagrams on the same piece of paper, and that led to EcoFact, most of the tiger project that we were involved in, and I still have that piece of paper, and I think it should be mounted. But the idea of zones moving and things, probably Mark and Bob in that meeting, and unfortunately, Mark's work always drew them the wrong way round, and no one understood that he showed where zones had come from rather than where they were going to go to.
yes.
And no one really understood what he was talking about. And it was just that simple 180-degree shift, and we would have sorted things out quite a few years earlier with Mark and Bob's.
Interestingly, Mark was at Bob's funeral.
He was.
Yes. Yeah, that's good. Nice to see him. Now quite an elderly gent.
Yeah.
Yeah, that's good. Yeah, but very instrumental in a lot of that early work. And now some of these ideas, as Mark has explained, is sort of mainstream in modeling. Quick final question to Mark. Any other comments, points? Okay, Dave.
Okay.
You want to go ahead? You're going to time yourself, are you?
The timer's on here and it started. I better get
No
talking.
excuse. Right, over to David. No introductions needed.
Right, I am here back in the 1980s. Jeff mentioned EcoLook, my signed copy. But this is what I'll be talking about, modelling. And I've been asked to talk about, well, in fact, I suggested, I wasn't asked. I suggested I could talk about modelling, and I think agriculture and energy was what came up. It's actually really, as it says at the top, it's Bob's style of modelling. That's very much what I'm looking to do. First of all, as we've heard with habitats, what is a model? We've all got our own ideas of what a model is. Compartments, mathematics, actual physical models, airfix models. We'll tell people a joke about that at tea time. That, by the way, was my daughter, who for a time was a model. This is actually from the Oxford English Dictionary. There are 34 different definitions of model. As a noun, you then got, I don't know how many for adjective and verbs. It's a very fuzzy term. It has a number of different meanings. If you're in Australia, a model actually means a prison. You've got to know who you're talking to. So today, what I'm going to try and do is talk about one of the ways that Bob used the word model. It's a method of identifying scenarios of change, how the world changes. And we've heard a lot today about Countryside Survey, but this goes beyond there, because it's not simply the environment, but it's also the drivers, which means often bringing in socio and economic factors. However, sorry to go back to it, Countryside Survey is central to this. In fact, Mark mentioned how back in the early days, couldn't do the full every square in Britain. The square on the left showing 1978 was that's I think 5,000 squares, all that could be done. Then we went to the all squares classification in 1990, and that keeps evolving as countries like Scotland say, you can't say anything about Scotland with information collected in England. Me pulling my hair out, never mind, but stock and change, vast amount of information. One of the important things is it's spatially and temporally co-registered. It's actually built on 1 kilometre square units, which a little bit serendipitous, I think, but it's the unit size we use, which seems to work very well. The information is holistic. It tries to be comprehensive, describes the whole thing, and it's flexible. You don't have to collect all the information at any one time. You can still produce timelines. You can still identify change. So how can you use all this Countryside Survey stuff to model? I've got 3 ways here that I think you can use it. There may be more, but for me, you can use it to say, effectively, what am I wanting to model? Define the question, or even refine it if you already know. It's a set of information which can tell you the question you should be asking and how you should ask it. It can provide you with data so that you can actually formulate a model, or if you've already got the model, you can actually use it to parameterize the model. I mean, I did quite a lot of that with critical loads mapping and things. You can also use it to set a framework, a structure. And this isn't so much the survey data as the stratification itself. And it's important because it allows you to spatially integrate information, tie things together. And it also then gives you a structure which you can interrogate in parts to give you an effective way of describing your results. So the issues that I was talking with, I'm afraid I'm back in the 80s now. This is when I first started, and what projects were we doing? I think the land use allocation was just about starting back in the early 80s, but we worked on intensification with why. We looked at alternative crops. We looked at agricultural land abandonment, but it was all using a similar system. Then, of course, energy, which some of you may know is the thing that I'm afraid I've worked on quite a lot, sort of in the last decade or so. But I started in the 80s. We worked on, we didn't call it bioenergy in those days, it was wood energy. With Philip Jones down in Dartington. It was called the Dartington model. We looked at wind energy, working with ETSU, the Energy Technology Supports Industry, and they had a thing called the NOABLE model, which was a national orographic, it was a lapse rate model. I forget the words, and of course you can look at pollution and critical loads. I could have done forestry, I could have done urbanization, I could have done recreation, loads more things. Bob was always different things. Oh, it wouldn't be good if we looked at that, and away we'd go. But the main thing was we were looking at the impacts of change. How will the world change because of this? So I've not got that long left, so I better get talking quickly. Just to give you an example, how it goes. And what I'm going to talk about is energy, of course, wind power. Now, there's a process which in many ways, Helle's talk was making me think of this same process, and it is almost a filtering process where you're taking information and filtering it. You start, the map you see here is an ETSU map. This was one of the ones we used. This is an average wind speed, but they had, the model produced a variety of different measures. So you have an idea of what the resource is. Question is, how many turbines can you put? That gives you the potential. How can I extract wind from there? Now, you can say, oh, just cover Britain with turbines, no problems, we've got the energy. However, it doesn't work, because what happens is you find that wind turbines can't go everywhere. So we then went through filtering for what's feasible. You can't put turbines next to buildings. In fact, we were only using 33-meter diameter turbines, but they said 10 times the diameter width, that's as close as you can get to a building. We looked at all, I think I was the first person in NERC to use ArcInfo as a GIS. And I spent ages trying to think, how do I pack circles into an irregular shape? Eventually, Bob said, why don't we use paper, cut out some paper circles? And that's what we did, and it worked. We then had to look at what was achievable, take the designations out. And of course, it produced results in different forms, statistical results. So the two lines I've left in here, one is showing if you take the physical constraints out, you've got about 54,000 squares in Britain where you can do this. And it gives you then just a rough estimate of what's the megawatt capacity of doing that. If you take the institutional constraints out, that shrinks down. But the important thing is, and you can't see, I'm afraid knowing what I'm doing, I can cheat a bit here. You've seen that one. I'll move it just for a second. So what we can see here is the wind potential, taking all the constraints out, is about 52,000 megawatts. That's the capacity. Depends how many hours it runs to give you the energy. The largest power station in the world is the Chinese Three Gorges Dam, which produces just under half that amount. But that is, or it used to be 6% of China's electricity supply. The biggest power station we have in Britain is Drax. Now it burns biomass as well as coal. It still burns coal a little bit. Sizewell's the largest nuclear power station we have in Britain. And Roscoe in the States is the largest wind farm. That's just setting this in context. The graph is just giving you it in terms of altitude. You can produce it as maps. I've got 2 maps here, and I'll cheat again so that you can read that. Not that you want to really read anything. The map on the right is giving you, if you like, the generating power index across the whole country, where the wind is high and where you can put most turbines. This one is when you filter everything out. You can even see where some of the national parks are. So that's giving you it there. But also, and this is something that Bob loved, different ways of presenting things. We've seen his images, but he actually always tried to use those to actually capture and pass information. Hopefully you saw the turbines appearing there. Just about done. I've got a minute left. What makes Bob's models unique? Okay, they're issue-led. You say, well, that's not that unique. His approach was always pragmatic. Again, he did have this thing about actually looking at an optimal scale. You look at the right level to do it. There was also a lot of unconventionality about it. He didn't mind using an expert's opinion. He would ask a forester, what trees would you plant there? He would tell the forester what the soil was, what the climate was, but he wasn't a case of, I've got a mathematical model here, which will tell me. He took the expert advice. Now, following that, oh, sorry, the last thing again, you maybe should read the last bit, which says co-registered. The data, because of the survey, because of his approach, is always appropriately co-registered, hopefully temporally and spatially. So it means your information matches. Now that's telling me to shut up. So I will in just a second, because I've got 2 little things to show you. One thing is, with all this, maybe we should be contacting the Oxford English Dictionary for a new definition. And they do have compound terms, so we could have the Bunce model. And of course, the final thing, which I'm sure is what we all here think, thanks, Bob, for everything.